So, when we picture a future run by AI, we tend to imagine these perfectly efficient, flawless systems, right? But here's a huge question we have to answer. How should these AIs, or agents, actually make decisions? Do we design them to follow one single master plan for the good of everyone? Or do we let them act in their own self-interest, kind of like we do? Okay, let's dive into this choice because it's a really fundamental one and see how it all plays out. All right, I want you to picture a big, bustling city, just filled with autonomous delivery trucks and drones zipping around. The goal seems simple enough: get every single package where it's going as fast as possible. But actually doing it, wow, that is a massive puzzle. How in the world do you coordinate thousands of these things without them crashing, causing insane gridlock, or just wasting a ton of energy? This is exactly the kind of problem AI was born to solve. So, one way you could tackle this is with a coordinated master plan. Seriously, think of it like having one single, all-knowing traffic controller for the entire city. This whole approach has a name. It's called multi-agent pathfinding. And multi-agent pathfinding, or math, is pretty much what it sounds like. You've got a bunch of agents, in our case, the drones and trucks, and the mission is to figure out the perfect path for every single one, making sure nobody bumps into each other and the whole system just hums along. It's like choreographing this one perfect, synchronized dance for everybody involved.
But you knew there was a catch, right? Here it is. Finding that one perfect, globally optimal solution for thousands of agents all at the same time is, well, as the computer scientists say, intractable. The number of possible routes and interactions just explodes so fast that even our most powerful computers just can't handle it. And that really matters, because if you can't find a good solution, you're looking at higher costs, slower deliveries, and way more pollution.
So what do? Well, researchers came up with this really clever workaround. Instead of trying to solve the whole shebang at once, they break it down into steps. First, they plan the truck routes, but not just for the truck's own deliveries. They plan them to act like a kind of bus system for the drones. Then, in step 2, they figure out the drone routes, letting them literally hop on and off the trucks to save time and energy. And finally, as a cleanup step, any truck that a drone didn't end up using just gets sent on its own fastest path. Pretty smart. And you can see exactly how it works here. On the left, that's the initial planning stage, where the system is figuring out helpful truck routes. Then on the right, you see the final plan, with drones perfectly assigned to board and alight from the trucks. It creates this beautiful, coordinated transit network. It's just a really elegant and practical solution to what seemed like an impossible problem. Now, here is the most crucial point about this entire approach. The main goal, the whole reason for being, is to minimize the total cost for everyone. It's not about making one drone or one truck super fast. It's about making the entire fleet, as a whole, as efficient as it can possibly be. It's a real all-for-one and one-for-all situation. But that's just one way of looking at the world. What happens if we just flip the whole script? What if our AI agents aren't programmed to cooperate for the greater good? What if they're selfish? Let's ask the one question that changes absolutely everything. What if each truck and each drone was owned by a different company, and its only goal was to get its own delivery done as fast as possible, no matter how it affects anybody else on the road? All of a sudden, this isn't an optimization puzzle anymore. It's a strategic game. And this really breaks down the two mindsets perfectly. You've got the coordinated system, which is all about the overall payoff, the best possible result for the entire group. But then you have the self-interested system, where each and every player is only worried about her own payoff. The goal literally shifts from we to me. To even begin to understand this world of selfish agents, we're going to need a completely new set of tools. We have to step out of the world of pure optimization and into the absolutely fascinating field of non-cooperative game theory.
So in a non-cooperative game, the basic assumption is that every player is acting on their own to get the best possible deal for themselves. We're not focused on some grand plan for the group anymore. It's all about the strategic choice each individual is making. Think of it less like an orchestra all playing in perfect harmony and more like a room full of soloists all trying to be the star of the show.
And there is no better, no more classic example to show how this works than the most famous thought experiment in all of game theory, the prisoner's dilemma. The setup is super simple. Two partners in crime get caught. The police put them in separate cells so they can't talk to each other. Then, they offer each one the same deal. If you confess and rat out your partner while they stay quiet, you get a light sentence. If you both confess, you both get a medium sentence. But, and this is key, if you both stay silent, you both get a very light sentence. This grid right here is the payoff matrix. It's the heart of the whole dilemma. Let's just walk through it. Take a look at that outcome where prisoner 1 confesses, but prisoner 2 stays silent. What happens? Prisoner 1 gets only 1 year, while poor prisoner 2 gets slammed with 10 years. Now look at the best collective outcome. If they both stay silent, they each only get 2 years. This grid shows us every single possible combination of choices. Okay, let's really get inside prisoner one's head for a second. You have no idea what your partner's going to do, so you have to think through both possibilities. First, you think, okay, what if my partner confesses? Well, my best move is to confess too, because 5 years in jail is way better than 10. Then you think, all right, but what if he stays silent? Well, my best move is still to confess, because 1 year is better than 2. You see what's happening? That whole line of thinking leads us to a really core idea in game theory. It's called the best response. It's basically the move that gives you the best personal outcome no matter what anyone else decides to do. And in this case, for prisoner one, confessing seems to be the best response every time. And this is the paradox at the heart of it all. Since both prisoners are rational people, they both follow the exact same logic. And so, they both choose to confess. It's the dominant strategy for each of them. But by each of them chasing their own best interest, they end up in a situation, 5 years each, that is so much worse for both of them than if they had just trusted each other and cooperated. This quote really just sums it all up perfectly. The prisoner's dilemma shows us that in a system of selfish agents, perfectly rational, perfectly intelligent decisions can lead to a group outcome that is, frankly, irrational and pretty terrible for everyone. So what we're left with are two completely different blueprints for how we can design our future. One that's built on total cooperation, and another that's built on strategic competition. This table really just lays it all out, side by side. Our coordinated system has a collective goal, it uses top-down planning, and it gets us to that optimal solution. But the competitive model? It's all driven by self-interest, it relies on bottom-up strategy, and, as we saw, it can lead to a much worse outcome for the group as a whole. And look, this isn't just a fun thought experiment about drones or prisoners. This tension, this choice between centralized control and individual strategy is at the absolute heart of designing almost everything, from smart traffic grids and energy markets to stock trading algorithms and even national economic policy. It's everywhere. Which, of course, brings us to our final big question. As we start to hand over more and more control of our complex world to AI agents, which model should we design for? Do we aim for the perfect but maybe fragile world of total cooperation? Or do we build systems that are tough enough to handle the predictable and sometimes paradoxical logic of pure self-interest? The choice we make is going to define not just the efficiency, but maybe even the entire character of the future we build.